Yeah, yes. So the other day we have discussed about superconductors. So in that superconductors, we know that. Let me share on this. Yeah. So before sharing, let me. So the other day we have discussed about superconductor and how the లాస్ట్ రోజు మనం చెప్పుకున్నాం ఆ రోజు మీరు కొద్దిగా బిజీగా ఉన్నట్టున్నారు. సో as you can see on the screen, everybody will seeing on the screen. Hello. Yeah. So you can see that is a magnet and superconductor. So basically the superconductors, before discussing the type of superconductors, let us discuss something about superconductor. So now let me share the screen. So I think everyone is seeing the screen. Is it screen is visible? Is the screen visible?
Yes, sir.
Yeah. Now let me tell what is about superconductor. So who discovered the superconductor? This phenomena. Who discovered this phenomena? Can anyone tell who discovered this phenomena? Yeah. So who discovered this phenomena? Don't know. Okay. Anyhow, the superconductor phenomena is discovered in around 1911 by a famous scientist called Camerling Onus. So Camerling Onus has discovered the superconductivity in the metal mercury. So mercury means Hg. What he has discovered, this is a complete zero resistance when you decrease the temperature. Suppose if we take the graph between resistivity, okay, and temperature. Temperature, let's measure temperature in Kelvin. So this is a resistance. So as you know that as the temperature increases, let me, as you know that when the temperature increases, what will happen? Temperature increases, resistance also increases. That one you know. As object become more and more heated. So when the object become more and more heated, it start having high resistance. So conductivity is decreases. So people expect that as you decrease more and more temperature, it will reduce the resistivity like this. So people know that similarly as you decrease the temperature, resistivity also decrease. So people thought like this. But what happened is in 1911, they have seen that when you come across very nearby the Kelvin, so sudden drop of temperature. This is called this is called superconductivity. So when you around some less than 10 Kelvin, when you come when you decrease the temperature less than 10 Kelvin, what is it? They have seen that resistivity is completely zero. So earlier they thought that in a normal metals, as you decrease the temperature, the resistivity also decreases. But at a 0 Kelvin, it is having certain resistivity. But when you in a superconductors, when you reach certain temperature, so what will happen when you reach certain temperature? The resistivity becoming completely zero. This phenomenon is called superconductivity. So in superconductivity, what is happen? When you reduce the temperature very much around Kelvin. So what is the relation between Kelvin and centigrade ki Kelvin ki on relation intama? What is the relation between 10 Kelvin and how many degrees centigrade? 10 Kelvin means how many degrees centigrade? How do you measure? How do you measure? How do you measure? Kelvin equal to 273 plus centigrade. So now 10 Kelvin means how much? C equal to 273 minus 10. That means what? Almost, sorry, minus 273 plus 10. I am taking, so minus 263 degrees centigrade. So that means normally water, what is the temperature at which water cools? Water freezes at what temperature? Hello. Hello. Hello, Mamata, Shirisha, Osharani. So water cools at what temperature? Freezes. ఐస్ ఏ టెంపరేచర్ దగ్గర ఐస్ అవుతుందమ్మా? హలో హలో anyhow, so minus 273. So they have discovered that some metals, like around some 28 metals, they have discovered less than 10 degree Kelvin, they are behaving like a superconductors. Superconductors, what is the materials? Some metals. Let me say, so many metals. So metals, just like we discovered, mercury is the first metal discovered with superconductivity by Kamerlingh Onnes in the year 1911. Now, intermetallic compounds also they have discovered superconductivity. What is meant by intermetallic compounds? Means two or three metals mix. When you mix two or three metals, so like alloys, they have discovered, or alloys. Alloys means a mixture of metals. So they have discovered that in this one less than some 20 degree Kelvin, they are behaving like a superconductors. Okay, so initially it is discovered around some 4 degree Kelvin. 4 degree Kelvin means what? How much it is a helium, liquid helium. So helium gas cools at what temperature? Around 4 degree Kelvin. So they have discovered very, very low temperatures. So at this very, very low temperatures, the resistivity becoming completely zero. That is called superconducting phenomena. So that is a very new discovery. So they thought that initially that will reduce, but they didn't thought that at certain temperature, the resistivity drops completely to the zero Kelvin, zero resistivity. So helium. Now, let us later, something around some year, some 1986, they discovered that not only metals, but certain ceramics. Ceramics means something like some bond compounds. So like some glass or like that, ceramics. Ceramics they have discovered in 1996. Ceramics are generally insulators. You know that in electrical poles, they will use insulator ceramics. So when you see the electrical wires, that wires will be at the poles. You can see some ceramic separating the electrical lines to the electrical pole. That is called ceramics. They are generally very good insulators, but they have discovered that when you reduce temperature of ceramics, reduce temperature, they are becoming conducting temperature at certain temperature. Reduce temperature, they start instead of insulator, they start conducting, superconducting behavior. So that is one of the greatest discovery. It is happened in 1986. Generally, we will see the conduction of metals. Metal will be conductors, but here superconductors, ceramics, which are generally the insulators at room temperature, they are start conducting, superconducting at very low temperatures. So what is the low temperature they have discovered? Around some 90 degree or 90 degree Kelvin, some 70 to 80, some around 90 degree Kelvin. So around 190 minus 190 degree centigrade, something around. They have discovered that they are start conducting, superconducting. What are the examples? YbCO, yttrium, barium, copper oxide. Yttrium, barium, copper, sorry, copper oxide, and LVA, BCO, lanthanum, barium, copper oxide. So, like there are several other which were discovered later, barium, copper oxide. So, like this. So, YBCO, these are all called high temperature superconductors. They are called high temperature superconductors. High temperature superconductors. Why temperature? Generally, people think that high temperature means generally what is the. So, generally, what is the temperature? What is the temperature we will see generally normally? So the high temperature means something around 1000 degrees centigrade, like that we will see high temperature means. So, but here the high temperature means, mama, we are seeing till then when we are seeing the superconductivity less than 10 degree Kelvin. But here they are behaving superconductivity around 90 Kelvin. This is called high temperature. Generally, in our the language of superconductivity, the high temperature is the 90 degree Kelvin. So they are until then they are seeing superconductivity only less than 10 Kelvin. But here they are seeing 90, 77, 80 Kelvin, around like that. So that is called high temperature superconductors. What are the examples of high temperature superconductors? High temperature superconductors, lanthanum, barium, copper oxide, and yttrium, barium, copper oxides, like that. So HTS, 90 degree Kelvin, like that. So is it clear? Is it clear? Yeah, I think it is clear. So now, let me take one screenshot. So, just a minute. Okay. Now, high temperature superconductors. So we are seeing the superconductors less than 10 degree Kelvin. Initially, they have discovered, later they have discovered intermetallics, which is less than 20 Kelvin. Later, they have discovered 90 Kelvin high temperature superconductors. So, like that, people have started discovering superconductors. So, actually, what is the target? What is the target we are aiming for superconductors? We are aiming actually the target. What is the target? It should be useful. Room temperature superconductor. We want a room temperature superconductors, but still people are searching for it. It will take so many years. So temperature superconductors. The room temperature means what? What is the room temperature in our room? Around the 25 degrees centigrade or 27 degrees centigrade. So people want at this temperature superconductivity at 27 degrees centigrade or 25 to 27. But it is very not at all possible at this moment. But people are aiming for it. So now it is okay. So here we have discovered that as you reduce the temperature, the resistivity starts decreasing. So that is this phenomenon almost we can see normal conductors also. As you reduce the temperature, the conductivity also increases. But for superconductor, it become at certain temperature. Like what is the temperature? TC, critical temperature. So at the critical temperature, what will happen? The superconductivity phenomena will be lost, as we have discussed earlier. This is the point. This is called TC. So if you cross the TC, it will behave like a normal conductor. Less than TC, it will behave like a superconductor. So so TC, temperature. So temperature is the boundary. Is it only boundary to behave control the superconductivity? No, there is a magnetic field. Suppose there is a superconductor. Suppose I have a superconductor. So suppose I apply the magnetic field, external magnetic field, north to south. So now suppose I apply the external magnetic field. So what will happen when I apply external magnetic field? External magnetic field is represented by using magnetic field is represented by the letter H. So when you start applying external magnetic field H, what will happen? It will oppose the superconductivity. It won't allow any lines of force. Suppose it's a superconductor. It won't allow any lines of force to pass through it. So it will oppose the lines of force to entering to it. So it will oppose magnetic field not to pass through that superconductor. So what will it is happening? It will oppose external magnetic field. So when you apply external magnetic field, it repels all magnetic field out of its body. This phenomenon is called Meissner effect. What is this phenomenon? Meissner effect. What is it, Meissner effect? It will oppose, pushes out. It don't allow any magnetic field enter into the superconductor. No magnetic lines of force or magnetic field allowed inside a superconductor. So what is happening till now? We discussed about only resistivity, but not magnetic field. Now we are discussing about a magnetic field also. So the magnetic field also that is the phenomena. So that is the difference between Meissner effect is the phenomena difference between normal conductor, perfect conductor, and superconductor. In superconductor, it in addition to less resistance, it also don't allow any magnetic lines of force to pass through it. So it repels all the magnetic field not to pass through it. That is called a Meissner effect. So this is a very important effect. It is called a Meissner effect. So now you are applying external magnetic field H. So when you applying, you are increasing the external magnetic field at certain magnitude of the external magnetic field. It stops again behaving like a superconductor. That magnetic field is called HC. That is called critical magnetic field. Critical magnetic field. So this magnetic field, if you cross this critical magnetic field, again it starts behaving like a normal conductor. Below it will act like a superconductor. So what is the boundary of magnetic field? HC, critical magnetic field. So if we cross the critical magnetic field, again it will start behaving like a normal conductor. It will lose the phenomena of superconductivity. So that is called external magnetic field. That is called HC. Now, is it only two factors, temperature and magnetic field? No. Suppose a superconductor is conducting the current density. So current density. So if you increase the current density, so you have only 10 minutes time. So current density also, if you cross the critical current density, again it do not show any superconductivity. So when you increase the amount of current passing through a superconductor, if you increase, there will be a stage at which it will stop behaving like a superconductor. That is called superconductivity. So if you draw the graph between three, suppose this is the temperature at point TC. So let me change it. At point a critical magnetic field, suppose HC, suppose a current density JC. So if you cross this boundary, it will stop behaving like a from surface. It will start behaving like a superconductor. So that is the important. So there will be the range in below which only it will act like a superconductor. If you increase all the parameters, it won't act like a superconductor. So you should remember these things: Meissner effect, current density, and superconductor. So okay, now we have discovered that superconductivity, some materials are behaving like a superconductors, and it has certain range of critical temperature, critical magnetic field, critical current density. Now, the question comes, what is actually happening inside a material? Inside superconductor, what is happening when you reduce the temperature? Or what is actually the reason for such a behavior of superconductor? So that is the thing scientists got out. We have to explain the theoretical phenomena. Not only experimental phenomena, we have to explain the theoretical phenomena. So the theoretical explanation, something which is a reasonable explanation, is given by three scientists. That is called, the famous theory is called BCS theory. This is called BCS theory. It gave explanation to superconductivity. What is BCS? B means what? He is a famous scientist, Bardeen. C means Cooper. H means Schrieffer, Cooper, Bardeen, Cooper, Schrieffer. So this is proposed a theory called BCS theory. It successfully explained the phenomena of less than 10 degree Kelvin. The superconductors, which are very original superconductor, less than 10 degree Kelvin, like that, it successfully explained why superconductivity is happening. So before discussing BCS theory, let me clarify that some of the points are important. What is that? It is a concept of a Cooper pair. Cooper. What is Cooper? Cooper is a scientist who told that electrons in a superconductor, instead of one electron, they pair up and to behave like a two electrons. That pair is called a Cooper pair. So what is the properties of these electrons? You know that electrons have a spin. What are the particles electrons are called? Fermions. What is the spin they are having? Half integral spin. Now, half integral spin. This called Fermi. They are governed by which statistics? Fermi Dirac statistics. So the phenomenon they are governed by Fermi Dirac statistics. So Enrico Fermi, Fermi means he's a great scientist, Enrico Fermi, and Dirac, you know that he is a Paul Dirac. So they have proposed certain statistics. You have read about it. They are concerned with half integral spin particles like electrons. Now, so Cooper has proposed that two electrons come together, condense together. So half spin, two opposing spins. So they have two opposite spins and they will combine, and net spin is zero. Net spin equal to zero. So half plus half ఉంటుంది ఇంకోటి minus half ఉంటుంది. Next spin, net spin is equal to zero. So it has a, now they will pair up and behave like a two pair. And now net spin is zero means which particle it is? When you have net spin zero, that particle is called a boson. Bose-Einstein statistics, you know that? It is a integral spin. Now they are combined together. That is the phenomena. So single electron becoming what? Two electron. So integral spin. What is happening? Single half integral becoming integral spins. So the particles, so there is a long range in a lattice. Lattice means what? What is meant by lattice? Arrangement of points like a molecules. The molecules are atoms in a crystal. So that's how. So we will discuss about BCS later. But Cooper pair means two pairs, two electrons come together. You have opposite spins. Their net spin is zero. So it is now this phenomenon is explained by Bose-Einstein statistics. You know that who is the Bose? He is statistics. He is an Indian. He is Sachendranath Bose. Sachendranath Bose actually got idea about these particles, and he proposed integral spin particles and their statistics. But it is so many scientists do not accept his theory, but Einstein supported this theory, and so Einstein. That's why later it became Bose-Einstein statistics. So that is a wonderful phenomenon. So that's why Bose-Einstein statistics. So these particles condense together and they have long range interactions. And so here you can see these act like a boson. So that's why today class. So next class tomorrow or day after tomorrow, we'll discuss in the next class about this BCS theory and copper pair. So copper pair means two electrons come together in a crystal lattice. So they are interacting with the lattice waves. So what is called lattice waves? Lattice waves means nothing but phonons. Lattice waves. Phonons. Light particles. What do you call light particles? Light particles are photons. Light particles, photons. So photons, lattice waves, phonons. So they behave like a phonons interacting with copper pairs, and that's how they will show the property of superconductivity. So all of you once again study and present on Monday to me this all the three people who has to present a type 1, type 2 superconductors, which we have already discussed in the class, and later on they don't given a chance. So like that. So take care. If you have any doubts till now. So today we discussed about various things about superconductivity and high temperature superconductors and like this. So any doubts? Mamata, Usharani, Shirisha, no doubt. Hello, 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 hello. Yeah, hello. Okay, okay. Come up with lesson, study the lesson, come next class. Bye.